Alright, this will be another lesson on working with hyperbolas. In this lesson we're going to get into rewriting hyperbolas in standard form. If you're comfortable with the ellipses and circles and the way we've completed the square, this will not be very different. As always, please put your pencils down. Alright, if you're watching this video you probably need a little bit of help. Learn from me, but then go back and make sure you can do these problems by yourself. Okay, well, to rewrite these equations in standard hyperbola form, we're going to have to complete the square. If I were you, knowing that the positive variable is going to have to go first, like looking at the x squared, you see how that's negative, and then I see the 9, and I see that's positive. The y's are the positive ones. So if I were you, I would start putting the y's in front right now. So I'm going to do a 9y squared, and then I'm going to match that up with 144y. Okay, and now I'll do my x's. So then I've got negative 16x squared plus 32x. Alright, and I'm going to move that over by adding it to both sides, and I'm going to get 16. Okay, now I will complete the square. Well, actually, first I will factor out this number in the front, the leading coefficient. So I'm going to have to factor out this 9, and I'm going to have to factor out this negative 16. If I factor out the 9, picture dividing by 9. So I'm going to have y squared plus, okay, 16y, alright, 144 divided by 9 is 16. Leave a space, alright, obviously 32 divided by negative 16, think of it that way. So I'll have x squared minus 2x. Got to be minus, not plus. Alright, remember, negative times a negative would give me a positive 32. Alright, a common mistake would be to make this a positive 2. Anyway, now it's time to complete the square. So half of 16 is 8. 8 squared is 64. So we'll put the 64 there. Now we're going to have to add something over here as well. It won't be 64 though. It'll be 9 times 64. Okay, so let's move this over a bit. Whoa, too far, too far. So if I do my 9 times 64, that's 576. So that's what I'm going to have to add over here. Meanwhile, half of this is 1. 1 squared is 1. But I'm not going to be adding 1 over here. Oh no! This is really negative 16 times 1. So that's really negative 16. So I'm going to put a negative 16 over there. Okay, now I can go ahead and rewrite this as a binomial squared. So this will be y plus 8 squared, and then minus 16, and then x minus 1 squared. Notice that the sign comes from the middle term. This is positive, so this is positive. Negative 2, so this will be negative. Meanwhile, over here, the 16 and the negative 16 cancel out. So I just have 576. So we're getting there. For hyperbolas, we need this to be equal to 1. So that's why I'm going to go back and divide everything by 576. Okay, 576, excuse me, divided by 9 is 64. So I'm going to have y plus 8 squared over 64. Alright, 576 divided by 16. is 36. So this is going to be x minus 1 squared over 36 is equal to 1. So there it is. This is the standard form of the hyperbola. All right, are we asked for stuff? No, that's it. All right, let's check out number 2. Okay, again, notice that the x term, the x squared is negative. So I'm going to put my y's in front again. So this is going to be 3y squared. Okay, and we'll match that up with my negative 60y. Okay, and then I've got my x's are right here. So I'm going to go with a minus 2x squared plus 4x. Alright, so I'm going to move that over there by subtracting it from both sides. So negative 268. Okay, I'm going to have to factor out the leading coefficient here. So this is going to become 3 times y squared. Let's see, 3 times 20 is 60. So minus 20y, leave a space to complete the square, minus 2 times x squared minus 2x. Did you catch that? Okay, negative 268. Make sure this is a negative 2. Remember, negative 2 times negative 2 would give me a positive 4. So this has to be a negative 2x. Now we complete the square. Half of this is 10. 10 squared is 100. But I will not add 100 to the other side. This is really 3 times 100, which is 300. Okay, over here, half of 2 is 1. 1 squared is 1. But I'm not going to add a 1 over here. This is really negative 2 times 1, which is negative 2. Okay, so now I can write this more compactly as 3 times y minus 10 squared. And the other one is going to be 2 times x minus 1 squared equals. Let's see what's going on here. So we've got, all right, we've got negative 268 plus 300 minus 2. Okay, so I'm getting 30. Okay, so this is going to be, all boils down to 30. Now, we know we need equals 1 over here for standard form, so let's divide everything by 30. Okay, if I do that, 3 goes into 30 10 times, so this is going to give me y minus 10 squared over 10. Okay, and this will be x minus 1 squared over 15. And that's equal to 1. Alright, and that's it. If all we are being asked to do is to write this in standard form, that's it. Hold on, that's going to bug me. Okay. Alright, now this time they're asking us to put it in standard form and then graph and fill in the information. Okay, so once again the x squared is the negative term. So once again I'm going to start off with my y. So y squared minus 6y minus 9x squared minus 36x. And look, the 36 is already over there by itself. Okay, This does not have a leading coefficient other than 1. So I'm going to leave that alone for now. This one has a leading coefficient of -9. So I need to factor that out. So that's going to leave behind x squared plus 4x. Again, think of it as dividing by this -9. Alright, -36 divided by -9 will give you a +4. So there you go. Okay. Now we can complete the square. So half of 6 is 3, 3 squared is 9. And there is no number out front that I have to multiply by, so I will just simply add 9 to the other side. Half of 4 is 2, 2 squared is 4, but I will not add 4. This is really -9 times 4, which is of course -36. So that's what you put over there. Now if I factor this, this is going to wind up being y minus 3 twice. Okay, I'll have my -9, and this will factor as x plus 2 twice. Now meanwhile the 36 and the -36 cancel out. So I've got 9. I need to have 1 over here, so I'm going to divide everything by 9. Okay, so this is going to give me my standard form, which is y minus 3 squared over 9 minus x plus 2 squared over 1. Alright, 9 goes into 9 one time. And this is going to equal 1. Okay, so this is the standard form that we needed. So now we can go ahead and graph it and write all the stuff down that we want to put. Now, is there a list somewhere? Okay, I guess there it is. Let's start with the center, because that's easy. It's going to be the opposite of this and the opposite of that. Alright, x comes first. So this will be -2 comma +3. So -2 comma +3. That's our center. So -2 +3 will be right there. Okay. Now this the positive term will always give us our vertices. So this tells us that our a value is 3. And this is where our vertices come from. And notice that this is the y term. So this 3 will be vertical, like the y direction. So I'm going to go up 3 and down 3 from the center. So up 3 and down 3. These are my vertices as predicted. Okay, so those vertices are -2 comma 6 and -2 comma 0. Alright, those are the vertices. Now it's time for the co-vertices. Alright, the co-vertices always come from the negative term. So because this tells me my b value, square root of 1 is still 1. And this is where my co-vertices come from. Because it's with the x's, I'm going to go left and right the x direction with my 1s. Okay, so that means there'll be a co-vertex here and here. So that is -3 comma 3 and -1 comma 3. Okay, it's time for the foci. Alright, now the foci I need the C value for that. I think there's enough space for me to do it right here. So the formula that helps me find the foci is this. C squared is equal to A squared plus B squared. So C squared is equal to 9 plus 1. C squared is equal to 10. So C is equal to the square root of 10, which is approximately equal to, let's find out. Okay, 3.2. Okay, the foci will always be on the same line with the vertices. So I'm going to go up 3.2 and down 3.2 like the vertices go, counting from the center. So up 3.2 is going to just put me just a little bit past this, and down 3.2 it's just going to put me just a little bit below this line. Okay, now as far as naming those foci, I'm not allowed to use decimals, so the x values are clearly -2 because they are precisely left 2. So it's going to be, they both will be -2 comma something. So it'll be -2 comma something. Notice I'm leaving kind of a lot of space. And then -2 comma something else. Now what will be this something? Well, because we have this radical involved, I'm going to have to write it based off the center. Now the y value, okay, to get this y value, start from the center, which is at 3. If I start at 3 and go up, I'm adding. If I start at 3 and go down, I'm subtracting. How much am I adding? C. C is radical 10. So this will be 3 plus radical 10. So that'll be my y value for the top one, 3 plus radical 10. And for the other one, it will simply be 3 minus radical 10. So these are the coordinates of your foci. Now, your asymptotes. Okay, to get the asymptotes, we're going to have to draw this little rectangle going from vertex to vertex and co-vertex to co-vertex. So I think I'm going to draw this off camera. Okay, so here's the rectangle I'm talking about. Okay, now we need to imagine the diagonals of this rectangle, because those will form the asymptotes of my hyperbola. So thinking about those diagonals, okay, I'm running out of colors to use. Should I use this like the center? Why not? Okay, keep an eye on the slope, okay? As I go from the center to a corner, imagine I'm going up 3 over 1. Okay, that's going to be important. Up 3 over 1. So I could do the same going in this direction. Down 3, back 1. Down 3, back 1. Down 3, back 1. Over and over again. Okay, so that gives me a slope of 3 over 1. Okay, so the slope is 3. Now if I look at it the other way, all right, I'm going down 3 over 1 like this. All right, and that's the same slope except it's -3 because I'm going down and over. All right, now these purple dots are sort of showing you where the asymptotes are. I'm going to go ahead and draw them as diagonal lines though. Okay, so these diagonals are forming the asymptotes. Please don't forget where your vertices are. Okay, this is a vertex right here, and this is a vertex right here. So that means as I go ahead and graph the hyperbola, hold on, the hyperbola will be going in this direction, where the vertices were. Okay, and these are asymptotes, so technically, even though it looks like it, you're supposed to imagine that they don't touch. Alright, but in reality it's going to be so close that it's going to appear to touch. Can't help it. Okay, so your hyperbola should look very much like this. Only neater. Okay, it's hard to do this with an electronic pen. Alright, I think we did everything. Oh, we have to say the equation of the asymptotes. So, this is very important. When you're doing the asymptote equations, let us use point slope form. Okay, remember, point slope form is like this. We do y minus y1 is equal to the slope times x minus x1. Okay? So the first of all, the slope. We talked about that when we first graphed the asymptotes. The slopes are positive 3 and negative 3. So you can write the equation of both asymptotes at once by putting plus or minus 3 for the slope. Now, the x1 and the y1 represent a single point. Well, there's only one point that's on both lines, and that's the center. Okay, so look at the center. All right, we are going to use the center as our x1 and our y1. Okay, so this will be my x1 and this will be my y1. So the negative 2 is going to come here and become x plus 2. It kind of does the opposite like we always do. So if I take this negative 2 and I use it, it's going to actually become x plus 2 when I plug it in. And I'm going to take this 3, that's my y1, so it's going to go here. Positive 3 will become y minus 3 in the equation. And there it is. You can just leave it like this. So y minus 3 equals plus or minus 3 times x plus 2. Now in your mind, understand this is really two separate equations. This is y minus 3 equals 3 times x plus 2. That's the upward sloping asymptote, and y minus 3 equals negative 3 times x plus 2. That's the downward sloping asymptote. Okay, but I encourage you just to leave it like this. Alright, number 4. Let's do number 4 the same way. Notice the x squared is positive this time, so this time I'm going to start with x squared and then follow up with the minus 90x. I'm putting the y's second because I see that they are negative. The y squared is negative, so there's my minus 4y squared and then the plus 32y. I'm going to move that out of the way by adding it to both sides, so that'll give me 163 over there. Both of these have a leading coefficient, so I'm going to have to factor that out. So this will be x squared minus 10x, leave a space, and then minus 4 times y squared minus 8y, leave a space, is equal to that 163. Notice this is negative, okay? Negative times a negative is a positive 32, so it's got to be negative. Now we complete the square. Half of 10 is 5. 5 squared is 25. I will not add a 25 over here, though. This is really 9 times 25. Which is 225. So that's what I'm going to add to the other side. Similarly here, half of 8 is 4. 4 squared is 16. I will not add 16 though. This is really negative 4 times 16. Okay, negative 4 times 16 is negative 64. So that's what I'm going to put on the other side. Okay, cleaning this up a bit, I've got 9 times x minus 5 squared, and then minus 4 times y minus 4 squared equals, okay, hold on a second, just shrink this down, it's distracting. Okay, so let's do our 163 plus 225 minus 64. Okay, so that is giving me 324. All right, I'm just going to divide everything by 324 now. Okay, hopefully all these go in evenly, so that would be helpful to us. Let's see how many times. Settle down, settle down. Whoa. What you doing? Let's see how many times. Sorry. 9 goes into 324. So 324 divided by 9. So that's 36. So this is going to give us x minus 5 squared over 36 minus. Okay, here I'm going to have my y minus 4 squared. So, 324 divided by 4. That's 81. Equals 1. So this is the standard form that we needed to be able to find all the other information. Now let's start with the center. The center of this will be the opposite of these. So positive 5, positive 4. Okay, so let's record that. 5, comma 4 is the center. Okay, so that's 1, 2, 3, 4, 5, 1, 2, 3, 4. So here's our center right here. What else you got? All right, let's do the vertices now. The vertices always come from the positive term. So this is going to give me my a value of 6. Notice this a value is with the x's. So I'm going to do my 6 in the x direction, left, right, from the center. So 1, 2, 3, 4, 5. Okay, I'm actually going to have to put it 1 over. And 1, 2, 3, 4, 5, 6. Okay, left and right. These are my vertices. Let's go ahead and write those down. So that's negative 1, comma 4 for the first one. And for the second one, that's 11, comma 4. Those are my vertices. Okay, how about those co-vertices? All right, the co-vertices always come from the negative term. So I'm talking a b value of 9. Okay, this is in the y direction, so that means I'm going to go up 9 and down 9. So it'll be easier for me to go down 9. So that's 4, and then let's see. So this will be down 9. Okay, so this is going to be at like 13 up here. So somewhere about here, I suppose. All right, it was starting off at 4. So if I go up 9, that's going to be up at 13. So those are my co-vertices. So like I said, what I have here is 5, comma 13, and 5, comma, what do I have here? Negative 5. Okay, so those are my co-vertices. Now for the foci. For the foci, I need my C value. Now for that, I need to use my formula that goes C squared is equal to A squared plus B squared. Okay, so that means C squared is equal to 36 plus 81. So that means that C squared is equal to 117. So C is equal to the square root of 117, which I don't think simplifies, but oh, 3 radical 13, genius. So C is equal to 3 radical 13, which is approximately equal to 10.8. Okay, the 10.8 will help me plot this. Now, understand that the 10.8, the foci, should always be lined up with the vertices, so horizontally. So I'm going to do my 10.8, almost 11, counting from the center. So this is over 5. So if I go, if I went 11, I would be at -6 here. Okay, so I'm going to just stop just short of that. Okay, and I'll do the same thing over here. Obviously, I've got to be like almost 5 to the right of this thing. I'm just eyeballing it. We'll be right about here someplace. Okay, now when I name it, I can't use the decimal. I have to use the 3 radical 13. So for my x values for the foci, notice the center starts off at 5. So this first one will be 5 minus 3 radical 13. And the second one will be 5 plus 3 radical 13. All right, I'm starting off from 5 because that's where the center is. So 5 minus 3 radical 13, comma something, and then 5 plus 3 radical 13, comma something. I still need the y value, even though that's really easy. All of these points have the same y value. They are all up 4. Okay, so the y values are simply 4. Okay, genius. Now we need the asymptotes. To get the asymptotes, I really need to look at the rectangle that contains the vertices and the co-vertices. I'm going to draw that off camera. Alright, there's the rectangle going to my vertices and my co-vertices. Now it's the diagonals that will be my asymptotes. So let me draw those diagonals off camera too. Okay, so these diagonals illustrate the asymptotes. All right, you can know the asymptotes based on the diagonals of the rectangle that we drew. Okay, now to write the equation of the asymptotes, because that's what we're supposed to put right here. We're going to use point slope form to do that. So remember, the point slope model works like this. We write y minus y, call it y1, is equal to the slope times x minus x1. So if you focus your eyes on the upward sloping asymptote, okay, first of all, let's get the slope, all right? Imagine the rise and the run. Now, it will be much easier for you if you remember how we drew this rectangle in the first place. Remember, we used this the 6 and the 9, okay? Notice the 9 is blue, the 6 is pink, Okay, so this was a rise of 9 and a run of 6, the blue and the pink. All right, it's up 6. It was up 9 and over 6. So there's my rise and my run is 9 over 6. So these numbers will always be involved in some way with your slope. So 9 over 6 is the slope that I'm going to put, except for one thing. 9 over 6 does reduce. Okay, so I'm not really going to leave it as 9 over 6, all right? Both of these are divisible by 3, so that'll really be 3 over 2. Right? Okay, so let's go ahead and put 3 over 2. Mr. Burton, are you going to take off points if I don't reduce? Yeah, I'll take off a point or two. Yeah, always reduce. So we have the slope. Now all we need is a point on the line. Now I could really pick any point on this line, but since it will make my life easier if I do the same point for both lines, we only have one option, the center point. Now we've already recorded that down here. The center is 5, 4. Let's let this be our x1, and this will be our y1. Okay, so the 4 is going to come right here. So this will become y minus 4. Okay, that 5 is going to come here for the x. So this is going to become x minus 5. Okay? Now, I could do the same thing for the downward sloping line, but if the first line has a slope of 3 over 2, then the other line is simply going to have a slope of negative 3 over 2. Okay, so I could rewrite this whole equation. Like I said, I'm going to use the same point. So I could just rewrite it and put negative 3 over 2 this time. And yes, it always works that way. All right, one will be positive, one will be negative, but otherwise they're the same. But if you want to, you can just cover both equations by just putting plus or minus. And I'll interpret that to mean both equations. Okay? And last but not least, let's go ahead and graph the hyperbola. You see that these are the vertices here. So this is where the hyperbola will go. Let me zoom out just a little bit so I can get more of a bird's eye view. Alright, so let's go ahead and graph those branches. Okay, so starting from the two vertices and following towards the asymptotes, it's going to be something like this. Okay, I messed that one up a little bit. It's not supposed to go backwards, Burton. Okay, it should be something like that. That's the idea. Okay, so that is it for number 4. Okay, write an equation in standard form for these parabolas. I think I can do this pretty fast. Let's see. Okay, I see the center is right here. Okay, the center is the point 0, 1. Okay, I'm going to use that. I see that the graph is horizontal, which tells me that the x term is going to go first. So I'm going to have x, well, the x term is 0, so I started to put like x minus something, but it really will just be x squared. So I have x squared over something. Alright, then I have minus. Now the y term will come next, and it will be y minus 1 from the center squared equals 1. My colleagues are being very loud out there, and I'm in the teacher's lounge. Anyway, all we need are these numbers down here. Now this will be the a value and the b value. Remember that the a value comes from the vertex. The a value is this distance right here, okay, between the center and the vertex. Alright, I guess to not confuse you, maybe I could do this one. Alright, 1, 2, 3, 4, 5. So my a value is 5. Okay, which means I will have 25. Okay, because this will be a squared. Now this will be b squared. Now the b value is the distance out to my co-vertices from the center. Okay, so I'm talking about, see, there's a co-vertex, so I'm talking about from here to here. So b is, that's 1, that's 1, 2, 3, 4. So b is 4. Okay, which means that I'm going to put 16 right here, b squared. And that's it, right? All we were asked to do is find this equation. And there it is. All right, let's do number 6. All right, same type of thing. Let's start with the center. This center is here at 0, 2. Right? Okay, yeah, 0, 2. Now, this is an upward, a vertical hyperbola. It's up, down. Because it's facing up and down, that's the y direction. That lets me know that the y term will be first. Now, the 2 is with the y. So I'm going to have my y minus 2 squared first. Okay. Now my x term comes second then. This will just be x squared because it's a 0, nothing to add or subtract. Okay, now this will be my a term. It goes with a vertex. Okay, the vertex is here. Alright, so this distance is my a value. So you can see that a is 2 from the center to a vertex. So that's why I'm going to put 4 here, because that's a squared. Now the b value, I'm going to put b squared right here. That's all about a co-vertex. Alright, here's a co-vertex right here at the side of this rectangle. Okay, so this distance right here is going to be my b value. So that's 5. 1, 2, 3, 4, 5. So I know that b is 5. That's why this is going to be 25. And that's all there is to it. And of course it'll be equals 1. Don't leave that off. So that is the standard form equation. Alright, that was number 6. Alright, I might have to finish this video. Got 2 more problems. I'm going to have to make a separate video for those. I got to go have lunch. Peace.